Welcome to Brain Vision.
Okay, so for this question, we can apply the energy balance equation. So we have E in is equal to E out. If we expand it, we have Q in plus MH1 is equal to MU2. Q in here is the heat that was transferred into the bottle, and M here is the final mass or the mass of air that was entered into the bottle. Okay, and H1 here is the initial enthalpy. U2 here is the final internal energy. If we do some arrangement here, we'll have the heat transfer is equal to M times U2 minus H1. So we know that M here is the mass, and mass of air can be expressed as a density of air times the volume, which is PV over RT, since the density can be expressed as a P over RT. Okay, so eventually have Q in is equal to PV over RT times U2 minus H1. So we know the pressure is given as 100 kilopascal. The volume is 35 liters, which is 35 times 10 to the power negative 3 meter cube. And the gas constant for the air is 0.287 kilojoule per kilogram times Kelvin. And we know the temperature is given as 22 degrees Celsius, which is 295 Kelvin. So now we need to use the table of the ideal gas properties of air. So at temperature 22 degrees Celsius, which is 295 Kelvin, the corresponding enthalpy is 295.17 kilojoule per kilogram, and the corresponding internal energy is 210.49 kilojoule per kilograms. So now let's plug in back to the equation to determine the heat transfer of the bottle. So we'll have Q in is equal to 100 kilopascal times 35 and times 10 to the power of negative 3 meter cube, and then over 0.287 kilojoule per kilogram times Kelvin, and then times 295 Kelvin, and then multiplied by 210.49 kilojoule per kilogram minus 295.17 kilojoule per kilogram. And this will give us the heat transfer of the bottle is about negative 3.5 kilojoule. The negative sign here indicates that the heat was transferred out of the bottle, okay, since it's negative. So therefore, since the question was asking us the net heat transfer through the wall of the bottle, so therefore we only need the magnitude. So therefore, have absolute value Q in is equal to 3.5 kilojoule. So therefore, the amount of heat that was transferred through the wall of the bottle during this filling process is about 3.5 kilojoule. Okay, and this is the answer for this question.